K. Fire hydrants. The designs, component materials, construction, manufacture, and testing of all fire hydrants shall conform to AWWA standard C5024 dry barrel fire hydrants. The bronze used for valve seats, drain valve, drain outlet, stems and all other hydrant components which are in the hydrant waterway is not to contain more than 15% zinc or more than 2% aluminum. However, where approved, brass drainage tubing may be used. Main valve shall be circular with a minimum opening of 5-1/4 inches in diameter, and shall be of the compression type closing with line pressure. Inlet connection shall be an elbow with AWWA standard bell designed for 6 inches mechanical joint, hub end, assembly as specified on the plans. The interior of the shoe shall be coated with an epoxy coating with a minimum thickness of 4 mils. Hydrants are to have 2 hose nozzles and 1 pumper nozzle. Nominal inside diameter shall be 2-1/2 inches for the hose nozzles and 4 inches for the pumper nozzle. Nozzle caps shall be secured to the hydrants with chains. Hose nozzle and pumper nozzle threads shall be in conformity with NFPA 194 standard for screw threads and gaskets for fire hose couplings, latest edition. Nozzles must be readily replaceable, threaded or cam-locked into the hydrant body. Nozzle cap gaskets are required and shall be of rubber composition. Hydrants are to open right, clockwise. Hydrants shall be painted with a suitable primer and finished with oil-based enamel aluminum paint from the top of the hydrant to a point 18 to 20 inches below the center line of the pumper nozzle. All fire hydrants having mechanical joint inlets shall be supplied with glands, bolts, and gaskets. Bolts shall be high-strength low-alloy steel meeting requirements of AWWA specification C111A metal weather cap and seal shall be provided. Hydrants are to have at least 1 drain opening. When the main valve is in a fully open position, leakage shall be no more than that specified in AWWA C502. The drain mechanism shall be flushed during each operation of the valve and shall be in accordance with the latest revision of AWWA standard C502. Barrel wall thickness and flow head loss conditions shall be in accordance with AWWA standard C502. Hydrant shall have non-rising stems. Hydrants shall be equipped with a breakable coupling on the barrel section and the stem. These couplings shall be at least 2 inches above the finished grade line. The breakable coupling shall be so designed that in case of traffic collision, the barrel safety flange and steam safety collar will break before any other part of the hydrant. The coupling shall be designed to afford the hydrant to rotate 360 degrees. Valve stems are to have a diameter of 1-1/4 inches or minimum size of 1 inches x 1 inches square. The design length between the center line of pumper nozzle and elevation of bury at ground line is not to be less than 18 inches. The bonnet section shall be designed so all bearing surfaces and stem threads are sealed in a lubricant reservoir. If oil is used as a lubricant, the reservoir shall be designed to allow easy filling through a fitting or plug. Where grease is used as a lubricant, the reservoir shall be sealed. The reservoir shall be adequately sealed with O-rings or other suitable system approved. The main valve upper plate and seat ring shall be bronze except where variations are approved. Thread the seat ring into bronze drain ring housing or other type of threaded bronze show bushing providing a bronze to bronze threaded connection. L. Polyethylene wrapping material. Polyethylene wrapping for ductile and cast iron water mains shall consist of a 4 mm thick tubular section of cross-laminated high-density polyethylene, having a high dielectric and tensile strength, for use in protecting and insulating cast iron and ductile iron pipe from the electrolytic action encountered in highly active soils. Polyethylene wrapping shall consist of an opaque cross-laminated high-density polyethylene sheet continuously thermally bonded to form a tubular section. The tubes may be supplied in bulk length on rolls or in individual pre-cut lengths. See the attached size and length chart, in accordance with AWWA C105-99, Table 1, for minimum requirements. Greater widths and lengths can be used in lieu of the minimal list. When supplied for specified pipe lengths, the tubes shall contain a minimum of 4 feet. additional material over the actual pipe length to allow for overlap. The sheet of polyethylene film utilized for the tubular wrapping shall be produced from virgin resins meeting raw material and physical properties of ASTM D1248 and ANSI/AWWAC 105, latest edition. The material shall be 4 mil x L, minted high-density polyethylene. The film shall be free of imperfections such as pinholes, tears, etc. After being thermally seamed into tubular form, the finished product will have a nominal thickness of 4 mils, with a tolerance of -10%. The polyethylene wrapping material shall have N-volatile constituents, the loss of which may affect ductility. The material shall have the following properties. Mechanical. The polyethylene film shall have a tensile strength per latest ASTM D882 test, of 6,300 psi min. The film shall have an elongation of not less than 100% of the test strip minimum per latest ASTM D882 test. The film shall have an impact resistance 800 gram min. For ATM D1709 method B, the film shall have a propagation tear resistance of 250 GF, minimum in machine and transverse direction, ASTM D1922. Dielectric. The film shall have a dielectric strength of 800 volts per mil of thickness per latest ASTM D149 chemical. The film shall be chemically inert, with a moisture absorption rate less than 0.01% in 24 hours. Marking requirements. The polyethylene film supplied shall be clearly marked, at a minimum of every 2 feet along its length, containing the following information. Manufacturer's name or trademark, year of manufacture, ANSI. AWWAC 105/A2015 minimum film thickness and material type, applicable range of nominal pipe diameter size, S, warning corrosion protection, repair any damage. M. Mechanical couplings. Mechanical coupling of dresser or similar type shall be used to connect plain ends of concrete steel cylinder pipe and plain ends of steel and ductile iron pipe in conjunction with the installation of butterfly valve sizes at 20 inches and larger, and to connect new and existing ductile iron water main in conjunction with casing installation in accordance with the details shown on the plans. The mechanical coupling shall consist of a cylindrical steel middle ring, 2 steel follower rings, 2 rubber compound gaskets and a set of steel bolts. The middle ring shall be flared at each end to receive the wedge-shaped gasket, which is compressed between the middle ring flare and the outer surface of the pipe by pressure exerted on the follower rings through the bolt circle. The flexible and transition couplings shall be manufactured to fit the type, size and class of pipe specified. Bolts shall be high-strength low alloy steel meeting the requirements of AWWA standard C111N. Air release assemblies. Valve body and cover shall be cast iron fabricated in accordance with ASTM A4835 or ASTM A126 Class B. Inlet sizes through 3 inches shall be screwed, National Pipe Taper Thread, NPT. Pipe sizes 3 inches and above are to have flanged inlets, 125 pounds ANSI B16-1. A protective hood or cowl shall be installed on the outlet of flange-bodied valves. Internal seat trim, float arm and pivot pin shall be stainless steel type 303 or 304. Floats shall be stainless steel ASTM A240. Other internal parts shall be stainless steel ASTM A240 or ASTM A276. Internal seat or orifice button shall be of Buna and rubber compounded for water service. Cover gasket shall be composition type, equal to Armstrong CS231, Garlock 3000, or Lexide NK511. Cover bolts shall be alloy steel. Valve body shall have a test pressure rating of 300 psi and working pressure rating of 150 psi. The air release valve shall be designed to vent accumulated air automatically. The outlet orifice shall be properly sized to facilitate valve operation at pressures up to 150 psi. The air release valve shall be either simple lever or compound lever, depending upon venting volume requirements. The air and vacuum valve shall be designed with the inlet and outlet of equal cross-sectional area. The valve shall be capable of automatically allowing large quantities of air to be exhausted during the filling cycle and also capable of automatically allowing air to re-enter the system to prevent a negative pressure during the draining cycle. The float shall be guided to minimize premature closure by air and to provide proper alignment for normal closure by floating on the water surface. Combination valves are to provide for both automatic air release under system pressure and to allow air movement during filling or draining operations. The combination valve may be housed in a single casting. The housing shall be designed to incorporate conventional or kinetic flow principles to properly vent the air without premature closure. Flanged sizes, 4 inches and larger, may be furnished in a dual housing. When dual castings are used, a bronze manual isolation valve shall be installed. This will allow the air release valve to be serviced when the system is under pressure. Blow-off assemblies and jumper connections. The materials required for both permanent and temporary 2 inches and 4 inches blow-off assemblies and 4-in jumper connections are shown on the plans.